So let's take a look at another section. We're going to talk about relative error. So we have 3 different vocab words here. We have expected outcome, absolute error, and relative error. Our expected outcome is what we would think would happen in a perfect world, all things being what they should be, perfection, utopia, what have you. So if we're talking about how a candy bar should be exactly 5 inches long, we know that in the real world it's going to vary a bit. But in a perfect world, it should be 5 inches long. Absolute error is the difference between what that candy bar should have been and what it actually is. The relative error is the percent difference. So we'd already talked about percent difference in the last 2 sections. So now we are talking about the relative error, the percent error. That's going to be a percentage. So we're going to subtract the 2 numbers. We're going to subtract the expected outcome from the actual outcome. That's going to be our absolute error. We're going to take our absolute error and divide it by our expected outcome to find our relative error. So let's take a look at this. A window screen is measured to be 25 and 3/16 inches wide instead of the advertised 25 inches. Determine the relative error and round to the nearest 0.1%. So it's bigger. We'll take our new or our actual, subtract what it should have been, divide it by what it should have been, and that'll give us our percent. So that'll give us 3/16 over 25, which is the same thing as 3 over 16 times 1 over 25. Let's put that in our calculator. 3 divided by, in parentheses, 16 times 25, and parentheses equals, it's pretty small, but that's just the decimal. We have to multiply it by 100 to get the percent, and it is 0.75%. The contents of a box of cereal were supposed to weigh 10.8 ounces, but are measured at 10.67 ounces. Determine the relative error, round to the nearest 0.1%. So we'll take what actually happened, subtract what should have happened, divide it by what should have happened, and see what we get. Grab our calculator. 10.67 minus 10.8 equals, divided by 10.8. Now that's the decimal. We need the percent, 100. And this is what I was talking about, where you should not be freaked out if you get a negative percent. This just means that it is 1.2% less than what it should have been. If it was positive, it would have weighed more, but this box of cereal weighed less, so we expect a negative number. That's perfectly okay. So negative 1.2%. We have tolerances. A tolerance is the maximum amount that a measurement is allowed to differ from the expected outcome. So that's putting a limit on our absolute error. So let's take a look at these US Mint examples. A US nickel, 5 cents, weighs 5 grams with a tolerance of plus or minus 0.194 grams. What's the lowest acceptable weight and the highest acceptable weight? So this just means the highest acceptable weight is going to be 5 grams plus 0.194. Lowest acceptable weight is going to be 5 grams minus 0.194. So highest is going to be equal to 5.194. Lowest is going to be equal to, I'll do the calculator, I don't trust my brain, 0.194, 4.806. Determine the relative error for a nickel that weighs 5.21 grams. So it's supposed to weigh 5, but it currently weighs 5.21. Minus what it should be, divided by what it should be. It weighs more than it should, so we should get a positive number. Remember to multiply by 100. 4.2%. It's 4.2% larger than it should be. If you'd like to, you can take a moment to work on problem 45. It's going to be very similar, but we are going to move on to this problem, finding the base after a percent increase or percent decrease. So if a number is increased by a percent, add that percent to 100, and we will use that result for R. Let's take a look at some examples. A sales tax of 8% is added to the selling price of a lawn tractor, making the total price $1,402.92. What is the selling price of the lawn tractor without tax? So what this is saying is that if we take whatever the price is and add 8%, we get $1,402.92. So we don't know how much it costs, so we don't know how much 100% of it is. But we do know what 108% of it is, right? We don't know how much Y is. We don't know how much 8% of it is. X plus Y equals 108%. So what is 108% as a decimal? That's going to be 1.08. So our new is $1,402.92. If we multiply our base times 108%, we're going to get this number. So 108, or 1.08 as a decimal, times our base, which we don't know what it is going to give us $1,402.92. So X is our base, Y is our tax, but we know that both together are 108%. So let's divide both sides by 1.08. Let's do that on our calculator. $12.99 is the original price. Let's use similar logic to do the next problem. U.S. population in 2018 was estimated to be about 327.2 million, which represents 7.6% increase from 2008. What was the U.S. population in 2008? So pop in 2008 is going to be our 100%, and we don't know what it is. Our population in 2018 equals the population in 2008, which was 100%, plus the percent increase. So the population in 2018 is 107.6%. What is this as a decimal? 1.076. Now you should be keeping this whole thing in mind when you see numbers that say percent increase or percent decrease. So don't worry about this unless you see the word increase or decrease. What is the US population in 2008? So we know that the 2018, the new, is 327.2 million, equals 1.076, whatever it was in 2008. Divide both sides by 1.076. So the original was 304.1 million.